All right, so I'm going to attempt to give you guys at least 10 extra problems a day with the full worked out solution explained. So here we go. Here's day one. If you would like to try the problems yourself, after I read the question, go ahead and pause the video before I begin doing the problem. All right, so here's our first problem on day one. It says this. If f of x is the piecewise function rad x when x is not 4 and 3 when x is 4, then the limit of f of x as x approaches 4 is what? So we recognize that this function is this radical function everywhere we're not 4, but then at 4, it's 3. So in actuality, what we have here is our square root function, right? But then at the point 4, which on this graph crosses at 2, on our graph, there's a hole. So it will go up until that point, there'll be a gap, and it will continue. And instead, our piecewise function has a filled-in hole at 3. Now, the question we have here is, what is this limit? Now, remember, in order to find the limit, we will be checking from both directions. So what we want to do is check the limit as x approaches 4 from the left, and check the limit as x approaches 4 from the right. Now, when we look at the graph here, we can see that if we come from the left, we are approaching 2. And if we come from the right, we are also approaching 2. So even though f of 3 is not 2, the limit is. So we have 2 and 2. Because the limit approaches the same value from each direction, we can see then that the limit is in fact 2. Now the actual value of the function is 3, but that's not what we're looking for here. All right, here we go. Question 2. If f of x is the function, the square root of x squared minus 2 over x squared plus 2, then find f prime of 2. All right, so we are going to go ahead and we are going to find our derivative of this particular function. All right, so in order to get f prime of x, we're going to start with the chain rule. So right now, this function is to the 1/2 power. So this will become 1/2, what we have inside, to the negative 1/2. Now we have to apply the chain rule because we have this function inside of that radical function, but that function itself is a quotient, so we will apply the quotient rule. So we have here x squared minus 1, its derivative, which is, x squared minus 2, and its derivative is 2x, times the bottom minus our numerator times the derivative of the denominator over our denominator squared. Now from here, instead of simplifying this, we will simply plug in our value for our derivative. So f prime of 2 is 1/2 over 2 squared minus 2 over 2 squared plus 2 to the negative 1/2 times 2 times 2, 2 squared plus 2 minus 2 squared minus 2 times 2 times 2 all over 2 squared plus 2 squared. And then we'll clean it up. So that is 1/2 over 4 minus 2, which is 2, 4 plus 2, which is 6, to the negative 1/2, times 4 times 6 minus 2 times 4 over 6 squared. Okay, this then becomes 1/2. And then because of this negative 1/2 power, I'm going to invert this fraction and make that a positive 1/2. And then this becomes on top 24 minus 8 over 36. And then this becomes 1/2. And then I'm going to just write this as radical 6 over radical 2. And then 24 minus 8 is 16 over 36. And then we're going to clean this up a little bit. So we get 16 rad 6 over 72 rad 2. Now, rad 6 divided by rad 2 is rad 3. And then 16 and 72 are both divisible by 4. Actually, 72 is divisible by 4. And so we get 4, and then 72 divisible by 4 is 18. And then both of those are divisible by 2. So we get 2 over 9 rad 3, which is A. All right, so question 3. A curve has a slope of 2x plus sine of x at each point xy on the curve. Which of the following is an equation for this curve if it passes through 0, 2? So we can see here that our slope is 2x plus sine x along a curve at our points x, y. Now what that means is our dy dx, our derivative of our function, is equal to the slope. So it's equal to this. Using separable differential equations, we get that dy is 2x plus sine of x dx. Integrating both sides, this becomes y is equal to x squared minus cosine x plus our constant of integration. Now, they give us the initial point, y of 0, as 2. So when we plug in 0 for x, 0 squared minus cosine of 0 plus c, it should come out 2. So this is 0 minus 1 plus c is 2. Add 1 to both sides, we see that c is 3. Therefore, y is x squared minus cosine of x plus 3, which is option C. All right, question 4. We have the limit of, as x approaches 1, of 1 minus x plus natural log of x over 1 plus cosine of pi x. So the first thing we should always try is direct substitution. So let's see if it works. So I plug in the 1 minus 1 plus ln of 1 over 1 plus cosine of pi times 1. Now on the top, that becomes 1 minus 1, which is 0, plus ln of 1, which is also 0. On bottom, we get 1 plus cosine of pi times 1, and then we see, if we use our unit circle, we see that at pi, our cosine is negative 1. So this becomes 0 over 0, which is an indeterminate form. Now, because it's indeterminate, we know that we can apply L'Hopital's rule. So what we're going to do is we're going to take the derivative of both the numerator and the denominator. So the derivative of 1 is 0. The derivative of negative x is negative 1. The derivative of ln of x is 1 over x. On the denominator, derivative of 1 is 0. The derivative of cosine of pi x is pi negative sine of pi x. following our chain rule. Now we can simply direct substitute. So we get negative 1 plus 1 over 1, which is over negative pi sine of pi times 1, which gives us negative 1 plus 1 over negative pi sine of pi, which sine of pi is 0. So once again, we get 0 over 0. So we're going to go ahead, because once again, it's indeterminate. We're going to apply L'Hopital's rule again, and we're going to take the derivative again of the numerator and denominator. The derivative of negative 1 is 0, and the derivative of 1 over x is going to be, so we are at x to the negative first, so we're going to go negative 1 over x squared over, and then the derivative of sine of pi x is going to give us negative pi squared cosine of pi x. So then by direct substitution, this becomes negative 1 over 1 squared, and then negative pi squared, and then we have cosine of pi times 1. The numerator becomes negative 1, and the denominator becomes negative pi squared times, what's the cosine of pi, but negative 1. So negative in the denominator becomes positive. So we have negative 1 over positive pi squared, which then becomes just negative 1 over pi squared. So our answer is B. All right, question 5. Let f and g be continuous functions, with f of 2 being 5. If the limit as x approaches 2 of f of x plus 1/2 g of x is 12, then the limit of g of x as x approaches 2 is what? So what we're going to do here is we're going to be playing with our properties of limits. So we have here the limit as x approaches 2 of f of x plus 1/2, constants can be removed from limits, the limit as x approaches 2 of g of x. And this is just applying the properties of limits, equals 12. Now, because these functions are continuous, we know that this value here is equivalent to the limit as x approaches 2. So the limit as x approaches 2 of f of x is 5. And we know that because of this continuity, no jumps, no holes in the graph. So we know then that this is 5 plus 1/2 the limit as x approaches 2 of g of x is equal to 12. We want to solve this for the limit of g of x, so we subtract 5 from both sides, and we get 1/2 the limit as x approaches 2 of g of x is equal to 7. Multiply both sides by 2, and we get that the limit as x approaches 2 of g of x is 14, which is C.